La, 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 la. All right. Polynomial functions. The class is recording now. As usual, you guys can go to the page of the recordings of the videos of the class, and you can see this video right there, right? So polynomial functions. Let's begin with what is this. Now, if you go to my class notes, this is what you're gonna find, right? This is what you're gonna find. A polynomial function is a function of the form blah 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 blah. Now, this looks awful. This looks like it is written in another language, and that is because it is. It is written in another language, right? I'm gonna do something different. I'm gonna try to explain what is a polynomial with some examples. So let's take a look at these ones, right? Let's take a look at these polynomials in here. We have been working with some of these. So for example, the first one, the first polynomial. This is a polynomial because it has two monomials. Did you guys remember this from 8th, 7th, 6th grade? What is a monomial, binomial, trinomial, polynomial? Did you guys remember this or not? All right, cool. So in this case, this is a binomial, right? It has two expressions separated by a plus or a minus. It is a binomial, right? Every single one of these can be said that these are polynomials, right? These are polynomials. This one has two, so it is a specific type of polynomial, a binomial. But this one is a polynomial as well. Now, what is the degree of this polynomial? Now, we remember that, right? The degree is the biggest exponent that we find in the expression. And since we cannot see any exponent in here, we know the biggest exponent is a 1. So the degree is 1 right there. The degree is 1, right? This is just a little bit of a review of what you guys saw in previous years, right? Polynomials, degree 1. What is the degree? Again, for the people who like to write down stuff, what is the degree? The degree is the biggest exponent that appears in the expression. I have it here. Look, the degree of a polynomial function is the largest power of x that appears. The largest power. So the biggest exponent. All right? Cool. So we know now this one is degree 1. This is the degree 1. All right? What is the name of this function? Now, we know this function. Maybe not all of you are going to recognize this type of function, but some of you will. Maybe Patiño knows it. What is this type of function, brother? Do you know it? We saw this function in the first term. Tefa, did you know it? Carol Zambrano, did you know it? This is a linear.
Teacher.
Danny?
Yes, I was going to say that that's linear, but you already
That is
said.
a linear.
But
Danny, you are
the second
correct.
one is a quadratic.
Man, this guy is good. All right, Danny, you are good, brother. You are good. All right, the first one is a linear function. The linear, why do we know this is a linear? Because of the form of the expression. Now, we don't know it as a and b. We know it as m for the slope, m, and c for the intercept, right? Y equals mx plus c. But it doesn't really matter. This is just numbers. So this is a polynomial function of degree 1 that happens to be a linear function, right? This is one that we have practiced. We have seen this. A linear function, if we plot a linear function, we are going to get a line. So that is why we call it linear, because we get a line. Let's go with the second one. What is the degree of the second one? Okay, so the degree, the teacher said that the degree, pretty good, Luna, pretty good. Nico Parra, pretty good. The teacher said that the degree was the biggest exponent, right? And I can clearly see here that the biggest exponent is 2. So the degree is 2. That's it. Think's not hard, right? Think is not hard. Now, what is the name of the function? We already got it from Mr. Daniel Osorio. Pretty good, Danny. This one is a function that we already practiced this term. This is a quadratic equation, right? From quadratic equations, we learn how to find the vertex, how to find how to use the quadratic formula, right? And how to find the roots and the solution and the x-intercepts and y-intercepts and all of that, right? We learned already how to do that. So these two polynomials we have already studied. These two polynomials we have already studied. But from here on, these are polynomials that we have not worked. Let's see. What is the degree of the third polynomial here? Again, the teacher said the degree, is the biggest exponent. So just like Nico said in the chat, the biggest polynomial, the biggest exponent, is 3. You can see it right here. Is the 3. Pretty good, Nico. Pretty good, Nico. So the polynomial is degree 3. The polynomial has a degree of 3. All right? How do we call this function? Now, you don't know this function. We haven't worked with this function, but we will. We will. This is called a cubic function. Go ahead and write it down, please. We know the first one. We know the second one, but we don't know the third one. How do you identify a cubic function? Pretty simple. Because of its degree. If the degree is number 3, the degree is 3, then the function is cubic. Or you can also see it because of the general form. Any function in this form is a cubic. Let me do an example. Here, let me do an example. Any function that has this form. So y equals, I don't know, 2x cubed minus x squared plus 7x, like that. Like that. Let's stop right there. This is a cubic function, number 1, because of the biggest exponent. Biggest exponent is 3. So we have a degree 3. But not only that, we can see clearly the values of A, B, C, and D. Right? We can clearly see those values. The value of A, simply because it's the one with the x cubed, is 2. The value of B, simply because it's the one with x squared, is -1, right? Look at this. The value of B is the one that goes with the x squared. The B is the coefficient of x squared. And in this case, it's -1. Remember, symbols, signs, are also part of numbers, right? What is the value of C? Okay, the value of C is the one that goes with x alone, right? So 7. And what is the value of D? What? There's nothing here. There's nothing there. There's no D. We're not adding something, right? So what is the value of D here? Well, in this case, the value of D
0
is 0. Pretty good, Danny. So we know how to do this even though we have not worked with cubic functions. We have spent a lot of time working with linear and quadratic. And because of that, because of we spending so much time with these two, we are now able to work with cubic ones without even having to study these functions. All right, let's continue with the next one. This polynomial function has a degree of 4. Nico Parra, and Danny Ruiz, you guys are correct. The degree is 4. The degree is 4. Why? Because the biggest exponent is 4. And how did you call this function? The name of this function is quartic. Quartic function. Again, how do we identify these functions? Because of the degree, number 1, and because of the form, right? We have 1, 2, 3, 4, 5 monomials, right? Okay, right. Now, these are not the only polynomials. We can have polynomials of degree 5, degree 6, degree 7, degree 8, degree 1000. Those polynomials exist. But in this in this group in ninth grade, we're just gonna study these ones. All right, this is gonna be the ones we study. Maybe in a quiz, I'll give you one of 5 grade, of degree 5. And you just do the same that I'm gonna teach you now. All right. If you like to take screenshots, go ahead and take one of these so that you don't miss this information. All right, let's continue. Let's begin with some exercises. Identifying polynomial functions. How do we know if a function is polynomial or not? How do we know that? That is going to be one of the first questions on today's classwork. So how do you know if A is a polynomial, B a polynomial, C a polynomial? How do you know if these are polynomials or not? Because of the expression. Take a look at the answer. A, the first one, A, F, this F, right? Remember, every single one of these functions have a name. This function is called F. This function is called G. This function is called H, right? This one is F, this one is G, this one is H. The number, the letter that appears at the beginning is the name of the function. So F is a polynomial function. It is. It is a polynomial function of degree 4. Why? Because it is compound by only monomials. And every single exponent is an integer. A natural value. A natural value. If we happen to have an exponent that is negative something, that exponent is not natural. It's an integer. So that means it's not a polynomial. Cool. So A is a polynomial and the degree is 4. Again, why do we know the degree is 4? Because it's the biggest exponent. Let's jump into the next one. Function G. Right, G is not a polynomial function. Why is this not a polynomial function? Why? Well, because of the root. Look, roots can be expressed as exponents. You guys knew this when we studied properties of exponents in the first term. Right, all the way when we were in the school, we studied properties of exponents. This is one of those properties. You can change the root into an exponent, but the exponent will have to be a fractionary. Since the exponent is a fractionary, it is not a natural number. So that makes it so that this is not a polynomial. All right. So roots are not polynomial. These are called radical functions. Radical. Why? Because of the root. Radical functions. We are not going to study radical functions now. All right. So forget about that one.
Teacher, you can explain again why it is not a polynomial function, please?
Sure. Danny, because of the exponent. Danny, look at this. Take a look at this part in here. Take a look at this part, right? I'm going to highlight it here. This part, Danny, this part is how you change from roots into exponents, right? You can change a root and make it an exponent. So take a look at this. This as an example. This square root of, no, cubic root, the cubic root of y. How did you change that into an exponent? That's actually pretty simple. You just do y elevated to the 1/3.
Teacher, your audio is failing. You cut in it.
Okay. Is it better now?
Yeah.
Thank you, Danny. Okay, so what I was saying was you can change roots into exponents. And all you have to do is this little number, put it as a denominator, right? That is what we did here. Look, this is a square root, right? So the 2 became the denominator. The problem now, Danny, is that this exponent is not a natural number. Do you remember natural numbers, Danny? Danny.
I listening to you, teacher.
No,
Don't
but I
worry.
asked you a question. Did you remember what are the natural numbers?
Yes.
Which ones? All right, so let's see. Natural numbers.
One,
1,
10,
2,
a
3.
100.
Uh-huh. Not Danny, you are correct. 1, 2, 3, and so on and so forth. 10, 11, all of those, right? 1/2 is not a natural number. And when the exponent is not natural, if the exponent is not natural, then the function is not a polynomial function. Every single one of the exponents have to be a natural number. Every single one. If we find one that is not natural, then it's not a polynomial. Did you get it, Danny?
Okay, teacher, thank
All
you.
right, cool. Beautiful. So this one is not a polynomial. All right. Now, let's see the next one. Is age a polynomial? Well, no. Age is not a polynomial function. In fact, you can see here you have two polynomials. The one on top of the fraction and the one under the fraction. Right? This is called a rational function. Rational. Why? Because this is the ratio of two functions. Since this is a ratio, we call them rational functions. So this is not a polynomial function. So now, every single ratio is not a function, is not a polynomial as well. So we have yes, no, no. All right. How about D? Well, F, question D, is a polynomial function. This one is a polynomial function. The polynomial function 0. That is the name.
Teacher, can you go back to me just a minute, please?
Sure. Take a screenshot, Danny. Take a screenshot, please, or take a picture.
Okay, teacher, thank you.
All right. Okay, so as I was saying, the function f is a polynomial. So whenever you find the value 2, the value 0, that is a polynomial. But that one doesn't have a degree. Don't say that the degree of 0 is 0. Don't say that, guys. Don't ever say that. That would be a mistake. What is the degree of this function? The answer is it doesn't exist. All right? That is the answer. This function, the function d, this one over here, does not have a degree. All right? But this is a polynomial function. Let's continue with e. All right, e, the function, this one, g, right, is a function as well. It is a polynomial function. This one is a polynomial function. This is a polynomial function. What is the degree of this function? The degree is 0, right? The degree is 0. Why? Because of what we have here. 8 can be expressed as 8 times x to the 0 power. X to the 0 is 1, so 8 times 1 is 8. This can be expressed like this. So this polynomial has a degree of 1. And last but not least, let's take a look at the question F. This one over here. Is this a polynomial? And more important, what is the degree of this polynomial? Well, from here, we cannot see. That is the reality. From here, we cannot see if this is a polynomial or not. Because look, here we have one monomial and here we have another one, but they are multiplied. They are not being split by additions or subtractions. So we don't know. We don't know. What do? We expand these. We do the operations to see what we get. This is what I mean. X minus 1 squared can be expanded for this. X squared minus 2x plus 1. This is a notable product. Productos notables. Do you guys remember this from when you were in 8th grade with Laura? Well, this is how you did it. You expanded this binomial into this. And from here, all you do is distributive property. So negative 2x cubed times x squared. This one. Negative 2x cubed times negative 2x. This one. And this one times this one, right? This is the final solution. So from here, we can now analyze and see if this is a polynomial or not. And we can see this is a polynomial. It has three monomials, right? They are separated by additions or subtractions. And the biggest exponent is a 5. So h is a polynomial function of degree 5. This is how you identify polynomials from the ones that are not. Let me say it again. If the polynomial has a root, then it's not a polynomial. If the function has a division like this, then it's not a polynomial. Cool, cool. All right, let's continue. Let's continue. This is also another one of the questions that you guys are gonna have today. How did you guys identify the reals of a polynomial? So I know maybe you guys forgot, but we saw this. We saw this in the review. Do you guys remember the review that we did, the Kahoot game? Did you guys remember that or not? Okay, I can see Patiño knocking his head. All right, thank you, Patiño. All right. So yes, we saw this, right? We know that zeros are also called solutions. Paso un momentico al español. ¿Listo? Anótelo, por favor, porque es que en el review se les olvidó y estoy seguro que se les va a volver a olvidar otra vez. ¿Qué son los ceros de una función? Así va a aparecer, mira, les va a aparecer en el saber 9, si hay saber 9, puede que no, pero sí, pues les va a aparecer así. Identifique los ceros de una función. Y usted se pregunta, ¿pero qué demonios es un cero? Mira, aquí yo no veo un solo cero. Aquí veo una X, un menos, un 1, un 2, una X, un más y un 3. Aquí no hay ningún cero. Ok, los ceros no son numeritos en la función. Los ceros son las soluciones de la función. Las soluciones. Anótelo, por favor, en algún lado. Zeros of a function are solutions of that function. Write it down somewhere, please. Write it down. All right, so how do we identify these zeros? Take a look at this. First, we take the function, right? And the first thing we want to do to identify solutions is make it so that f of x, instead of f of x, look at this. Please, guys, stop writing. Please, stop writing. Dani, Luna, Majo Altamar, stop writing. Danny, thank you. Look at the screen, please. Look at the screen. Look at what I'm going to do because this changes everything. All right? Look at this. Did you see what changed from the first line of math to the second line of math? What is the change between those two equations? Well, the change is that instead of this part, instead of f parenthesis, x parenthesis, instead of f of x, I have a 0. That is the change. That right there is the change. And that is the first thing we are going to begin with to be able to find solutions. Listen, you don't do this, and you are not going to be able to find your solutions. This is the first step. Instead of having the function equal to f of x, you're going to have the function equal to 0. And now, the function being here, you can even put it in a calculator and the thing is going to solve itself. I'll show you how to do that in a sec. First, I'm going to show you how to do it by hand and then with the calculator, all right? So the first step, equaling to 0. From here, we know, because we studied, did you guys remember this? We studied. When we have a function that happens to have a multiplication equal to 0, we can split this function into two. The first factor, so the first multiplication, the factor is going to be equal to 0. And the second factor is also going to be equal to 0. We saw this when we were studying quadratic functions. Did you guys remember this or not? Right, Patiño says yes. All right. Look, here you have a multiplication, right? You are multiplying this times this. This is the multiplications, right? So you are going to have the first multiplication here. And you're going to have the other multiplication there. Both of these are going to be equal to 0. Look, equal to 0, equal to 0. Right? This is the first step and the easiest process. Why? Because now that we have these both equal to 0, we can isolate the values of x individually. Maybe you guys don't remember how to do this, but it is absolutely simple. Look, in the first part, we have a quadratic equation. We know how to solve those. Take a look. To be able to take out the exponent, I'm going to pass it to the other side as a root. So we have the square root of 0 equal x minus 1. Again, we are isolating the value of x. So I pass it as a root. From here, what is the square root of 0? Anybody knows? In the chat, please. What is the square root of 0? All right, Tefa knows. Thank you, Tefa. Square root of 0 is 0. Because you're looking for a number that multiplied itself twice gives you 0. And then the number is 0. 0 times 0 is 0. So the square root of 0 is 0. Here, there, I just solved it. What is the square root of 0? 0. Pretty good. Tefa, Dani Ruiz, and Majo Altamar. You guys are correct. From here, all I need to do is isolate the value x. Despejar. If I isolate x, I need to pass -1 to the other side. If -1 is negative, right? So I'm going to pass it as positive. So 1 equals x. From here, we have one solution. Remember, we're looking for the zeros, so the solutions. We have 1, x equals 1. One of the solutions will be 1. How do we find the other one? Well, the other one, we are going to find it from here, from the other equation. In this equation, all we have to do is isolate. So the positive 3, we're going to pass it to subtract. We have -3. This is the other solution. -3 equals x. All right. Take a look at this. The zeros are 1 and -3. Those are the zeros. We just found them. Look, 1 and -3. So this is the process, guys. This is the process. This is what you have to do. You're going to practice today, right? You are going to practice today by doing this. In most of the questions, I'm going to ask you to find the zeros of a function. So this is the process you do. You're going to change the f of x by 0 and then split, right? From here, the zeros are 1 and -3. That is the solution. But remember, zeros can also be named x-intercepts. De nuevo, lo digo en españolito por si se me pierden. Esto también lo vimos en el review que hicimos de Kahoot. Ceros se pueden llamar soluciones o interceptos con X. Esos son los 3 nombres que tiene las soluciones. Las soluciones se pueden llamar ceros, se pueden llamar soluciones o se pueden llamar x-intercepts. Esos son los 3 nombres. No se les vaya a olvidar, por favor. En algunos exámenes aparecerá, encuentre el x-intercept. Y el que no estudió dirá, ay, no sé cómo encontrar el x-intercept, profe, yo solo sé encontrar ceros. Es que es lo mismo, ¿no? Es que es lo mismo. Entonces toca acordarse los nombres, ¿listo? Los nombres son importantes. Nombres son importantes. Okay, remember, zeros are x-intercepts. So if we take a look at the graph, look, this is the graph of our function. I use GeoGebra for this function here. I use GeoGebra for this function, right? I just wrote down this function in GeoGebra. This is the function, right? And we can see those x-intercepts right there. Look, the intercept 1 is right here in the middle, in the middle of 0 and 2. That is the first x-intercept. Remember, x-intercepts are points that are on the x-axis. And right there is 1. The other one, negative 3. The other one, it is right here. Look at that one. Between negative 4 and negative 2. Right in the middle. That is the negative 3. Look how beautiful is this. Finding the solutions gave us the x-intercepts.
Teacher, I have noticed that the zeros are, well, not exactly the same numbers that appear in the problem, but, well, are
Kinda.
the same numbers but in
Uh-huh.
different symbols.
Danny, that is why, brother, that is why I like you, Danny. That is why I like you. You just said something extremely powerful, Danny. No, listen, I am not making fun. I am being for real. You just said something really powerful. Look, one of the zeros came from this. 1 0 is 1, but instead of being negative, is positive. And the other 0 is negative 3, but instead of being positive, is negative. Danny, you are correct. There is a relation. There is a relation between the values in the factors and the solutions, the zeros. Not precisely the same number, but the number with the different sign. Pretty good, Danny. Good observation, brother. Good observation, Danny. Keep it up. Samuel Nunez says, Mr. David Rodriguez has internet problems. Thank you, Samuel. Thank you. I appreciate it. Thank you. All right. Let's jump into another exercise. Let's jump into another exercise here. Exercise number 2, guys. Exercise number 2. Find the zeros, so the solutions, of this function that we have over here, right? This is the one we're going to do. All right, solution. How do we begin? Again, how do we begin? The first step, guys, I told you before, but the first step is instead of this, instead of f parenthesis x parenthesis, we are going to write a 0. There it is. There it is. Everything else stays the same. From here, we will find the solutions, the zeros. But how? All right, it's pretty simple. Just split these multiplications, and equal them by 0. But look at this. How many multiplications do we have in here? All right, we have 1, x multiplied by this. So we have 2 multiplications, and then multiplied by this. We have 3 multiplications. We have 3 factors. We have 3 factors, meaning that we are going to split this into three equations. In the previous exercise, look, take a look at the previous exercise. We only had 2 multiplications. That's right, only 2. 1 factor, another factor. 2 factors, 2 multiplications. So we split this into 2 functions, 2 equations. But here, in this one, we have 3 multiplications. So look at this. We have the first one, x, right over there, equal to 0. The second one, 2x plus 1 squared. 2x plus 1 squared equal to 0. And the last multiplication, 3x minus 1. 3x minus 1 equal to 0. Look, I just split it, every multiplication, every factor, and also I equal those to 0. All right? So again, step 1, change f of x by 0. Step 2, split the factors. Step 3, isolate. Bianca Rachel says, profe, perdón por llegar tan tarde. Estaba en el médico que tenía que sacar unas cosas. Bianquita, don't worry. I get it. Don't worry, all right? You're excused. Don't worry, Bianquita. Remember, we are recording the class, all right? So you can always take a look at the video and learn this, all right, Bianca? Okay, cool. So let's continue. How do we isolate x from these equations? All right. The first one is pretty simple. Why? Because look at this. 0 equal x. We already have one of the solutions. We are looking for solutions, right? So we have the first one, 0. It says so right here, 0 equals x. We have the first one, guys. All right, pretty good. All we have to do is find the solutions for these two. The first one, to take out the exponent, Remember, we are isolating here, right? We are isolating x. So to isolate, we are going to pass everything to the other side. The exponent passes as a root here. Again, what is the square root of 0? Well, it's 0, right? And from here, we just isolate regularly. So plus 1 becomes a negative 1, right? We just pass it to the other side. We are adding a 1, so we subtract a 1 in the other side. And the 2 here, the 2 is multiplying. So we're going to pass it to divide. In other words, we now have our second solution. Negative 1/2. Negative 1/2. And look, just like Danny said, there is a relation between the zeros and the numbers in the factors. Look, 1, but with the other sign, negative 1. But in this case, we have to divide by these numbers. So negative 1 over 2. Negative 1 over 2. There is a relationship. Yes. All right. What about this one? What about this one? Can you isolate it in here? Well, sure, right? All you have to do is just pass the negative 1 to the other side as positive, right? So we have 1 equals 3x. And then the 3, well, the 3 is multiplying. So we're going to pass it to divide. We have 1 over 3 equals x. Okay? Cool. Now we have our 3 solutions. 0, negative 1/2, and 1/3. 3 solutions. Can the solutions be fractions? Sure. These are fractions. That is okay. Solutions can be fractions. Can the solutions be decimals? Sure. These solutions can be decimals sometimes. The solutions don't always have to be integers. All right, take a look at the following. We know now that the zeros are 0, negative 1/2, and 1/3. Remember, zeros are solutions, right? Cool. So if we were to plot this in a Cartesian plane, this is the drawing. Again, I took this figure, this graph, from GeoGebra. This is the graph of this function over here, of the red. Okay? And look at that. You can clearly see the solutions as x-intercepts. The first one, the 0, is right here. Right in the x equals 0 is right there. The function passes through that point. How about the second one, negative 1/2? Look at this. Is this one in here? Negative 0.5. You can do this in the calculator. You can put negative 1/2 in the calculator, and it will give you negative 0.5. It is right there. Look at that. How beautiful is this? And last, 1/3. Right, 1/3. If you put it in the calculator, it's gonna give you around here, 0.333333333. Around here. Around here. Zeros can be seen as x-intercepts, And this is the process. This is how you find it. All right? Okay, so far, guys, we have seen how to find the zeros if I give you the polynomial. But what if I gave you the zeros and I ask you to find the polynomial? So how can you work backwards? Take a look at this example, guys. All right, let's take a look. Man, this is where things get fun now. All right. I am giving you the zeros of the polynomial, the x-intercepts, the solutions, -3, 2, and 5. I am giving you those solutions, but I am asking you to find the polynomial. I am asking you to find the polynomial. How can we do that? In this case, we are working backwards. Take a look at these guys. Solution. I am going to begin by explaining a little bit slower what Danny said before. Again, I am going to explain this, but Danny realized this. before my explanation? I was surprised, Danny. I was surprised. Pretty good job, Danny. All right, take a look at this. Let's begin by working with the first zero, the first solution. -3. Look, if -3 is a zero of the function, then x plus 3 is a factor of the function. How do we know what? How do we know that? Well, because, look at this. If we said that x plus 3 is one of those multiplications, remember, the word factor is a fancy word for multiplication. Lo digo en españolito. Esto de factor, esto es solo una palabra bonita, una palabra rara y bonita para cuando uno multiplica. ¿Ok? Entonces, cuando uno dice x más 3 es un factor, pues uno está diciendo que x más 3 es una multiplicación. En realidad aquí estoy sumando, ¿no? Pero esto está multiplicando a algo. Está multiplicando otra cosa. Porque es un factor.
Teacher, it is the same relationship that I found.
Uh-huh. Yes, Danny. Pretty good, Danny. All right, so we know this is a factor of the function. Why? Because if it is a function, if it is a factor, we can equal it to 0. And if we isolate, we know that the solution was -3. So in fact, we are working backwards. From the 0, from the solution, we found the factor, the multiplication, simply by changing the sign. This was -3, so I put it as +3, x plus 3. In general, guys, let's say that we have any value r of as a 0 of a function. So any value r is a 0, right? Then x minus r is a factor. It works. Look, for the first one, the first value r was -3. So we have x minus -3. Minus and minus, right? X minus -3. So we have double minus. That is a positive. So the first factor is x plus 3. In other words, simply change the value that you have in the 0, and you're going to have the factor. So what are the factors of the function? All right, the first factor, x plus 3, because it was negative here, so we put it as positive. The second one, since the 0 is 2, the solution is 2, then the factor is x minus 2. X minus 2. The last solution, 5. So the factor is x minus 5. In other words, change the sign and put it as a factor. -3, x plus 3. 2, x minus 2. 5, x minus 5. That's it. Now we have the factors. But hey, look, listen. Hey, guys, listen. Hey, guys, listen. We don't have the function yet. We haven't done the function. And this is what the question is asking us. The question is asking us to find the polynomial function of degree 3. That is what the question is asking us. To find the function of polynomial, the polynomial function of degree 3. We only have the factors. We haven't done the function. Take a look at this. The function is f of x equals the first factor times the second factor times the third factor. And that is it, guys. We are done. It is that simple. We are done. We are done, guys. That's it. That is it. Now, how do we know if this is of degree 3 or not? Remember, the question is saying, find a polynomial function of degree 3. Well, in here, every single exponent is to the first power, is to the 1. The exponents are 1. How do we know if this is degree 3 or not? This is where things get a little bit more mathematical. All you have to do is expand this, multiply. X times x, x times -2. 3 times x, then 3 times -2. You're going to do the distributive property. And once you're done with those two, you deal with the third, distributive property. This should be the solution. I did it already. And now we can see that simply because we have x times x times x, we know that the biggest exponent is 3. This is, in fact, a polynomial function of degree 3. We did it, guys! No? We did it! We did it! We found it! Again, from the zeros, we found one function. Now, question, guys. Is this the only function that will give us these zeros? Not necessarily. Not necessarily. There are infinite functions that will give us these zeros. So if you happen to find another one different than this, that is okay. This is not the only answer. Everybody can have different answers. Now, I don't think you're going to have different answers in today's classwork because this is the easiest process. To find different functions, you're going to have to do different processes. And I'm teaching you the easiest. All right? Cool. So now we do some exercises. Not these ones. No, we're not going to do these ones. We are going to jump into, what is the name of the platform? Into Alex. We're going to jump into Alex, guys. So please go to alex.com. Go to alex.com and do the exercise of the day. All right? You can find it as classwork number 3. You are only going to have until 12 and a half, 12:30. All right, guys? Remember, if you have any doubts, I am here for you. You can always ask me and we can do the exercises together. But until the next time, we're gonna stop the recording here.